In this example, we want to evaluate the integral which is given over here on the integrand as x square times square root of x cube plus 10, and we would like to use the substitution rule here because from just the basic antiderivative rule it's difficult to integrate. So we just want to try if the substitution rule helps. So if that is the case, this is what I want to assume. So because under the square root of sign we have this x is x cube plus 10, right? So if that is the case, I just want to suppose that is kind of u. So if I want to suppose that u is x cube plus 10, with the help of this I just want to write down this given integral in much more simpler form, and let's see if we can do that. Okay, so here is the idea. So once I suppose, let's say u is x cube plus 10, my next task is to try to see if I can find the differential du, which is the derivative of the x cube plus 10 multiplied by differential dx. So what is the derivative of x cube plus 10? Derivative of x cube is 3x square, right? Derivative of 10 is 0, so 3x square is the derivative of x cube plus 10, and just multiply by the differential dx. So that should be our differential du. So now we have kind of two different relation here. One, we have suppose u is x cube plus 10, and another is differential du is equal to 3x square plus 3x square times dx. Now with the help of these two relation, we just try to change our this given integral in terms of u. So right now we have everything as a kind of in terms of x, right? So we just want to change that in terms of u, and then see if that change form is much more simpler from than the given one. So that should be our task. So how can we do it? So we have over here x cube plus 10 that we have suppose is u. So over here you can see that term is over here x cube plus 10. So why don't you write down instead of x cube plus 10 over here is u. So let's do that. So we have the integral sign over here. So instead of x cube plus 10, if we write down u, then we will have square root of u, right? Because we have square root of x cube plus 10 is over here square root of x cube plus 10. So instead of that we can write down square root of u. So if you do that, what is left over is x square times differential dx. So that's the term left over. So then how do we substitute that in terms of u? Now how can you replace that, right? So that should be the observation we need to have. But over here we have another kind of relation over here. Differential du is 3x square times dx, and then over here that term is we have already received, so x square times dx. So that's what we were looking for, and then that term is over here. So then instead of that term x square times dx, we can actually solve for that and then try to see if we can write down in terms of u. So why don't we then use this equation and then try to solve for x square times dx. So let's do that. So if we solve for x square times dx, that means we can divide by 3 on the both side, right? So when we do that, then we have 1 over 3 times differential du. That's what we have, we will obtain, right? If we solve for x square times dx over here from that equation. All right, so if that is the case, instead of this x square times dx, right, let's write down 1/3 du. So if you do that, so we'll have square root of u times 1/3 du will be here, right? So that would be our changed kind of integral. Now let's try to see if it is the simpler form. Here we have 1/3, which is just a constant multiplied by square root of u. So if that is the case, we can use the constant multiple rule and then take the 1/3 out, and what is left over is just square root of u. We thought at the beginning the problem is, oh, we have x square times square root of x cube plus 10, how to integrate. But now it's much more simpler with that substitution. We just have square root of u to integrate, and I believe we know from the basic rule we know how to integrate that, right? So because the square root of u means what, if you want to change that into the exponent form, that can be written as u to the power 1/2, right? So then we can just use the power rule, right? So to integrate, because 1/3 is a constant, so the multiply by u to the power 1/2 is what, something like a power function. So if you want to use the power rule here, so we'll have u to the power 1/2 plus 1, so which will be 3/2, right? And then we just need to multiply by the reciprocal of this new power, so which is 2/3, and that should be the entire derivative of u to the power 1/2 plus the general integration constant. So then we have 2 times 1 is 2 divided by 9 times u to the power 3 half plus c. So we already integrate, there is no integral sign here, right? So because we have already did that operation, but now the only thing left over is, if you look into here on the given problem, it's actually given as a function of x. Our answer is given as a function of u, and which is kind of a mismatch. But then we can correct that, because we have suppose u is actually x cube plus 10, right? So if that is the case, why don't we plug that in over here? So if you do that, and then everything would be as a function of u, right? So our answer would be, so we have 2 over 9, and then u, if we suppose that is what, now if you replace back that as x cube plus 10, then we have 2 over 9 times x cube plus 10 to the power 3 half plus c, and then that should be it, because this is the entire derivative of this given function x square times square root of x cube plus 10, and that's how we evaluate that given integral.